Panelists, we have a couple of them right here. So I thought we'd start with introductions. I'll let you guys introduce yourselves first, and you are both PhD students, right? So I'd be happy if you also told everybody what you are researching related to Bitcoin. So this is the Bitcoin and Academia panel, right? So specifically what topics you're interested in. So go ahead, Christian.
This works, great. So yeah, my name is Christian Decker. I'm a PhD student and researcher at the Distributed Computing Group at ETH Zurich. And I basically research networking aspects of Bitcoin, namely how information propagates in a network, how consensus is reached, and how we could improve and make it scalable, which we heard about yesterday already.
Hi, so my name is Iddo. I'm a PhD student at the Technion in Israel. So my research is divided into two. So one part is just assuming that Bitcoin works well and then trying to figure out what kind of interesting feature we can get out of Bitcoin. So, for example, secure multi-party computation, fair coin tossing, and stuff like that. Incentivizing delegated computation. And the other part is not assuming that Bitcoin works well, but trying to analyze whether or not Bitcoin works well. So I have a talk later today about proof of stake and whether that can help. And so that is the other kind of research about analyzing cryptocurrencies, the decentralized cryptocurrencies in general, and seeing whether they work or not. And also involved in Ellie's research, we will probably arrive soon about succinct proof systems and how they can be helpful for Bitcoin.
Okay. Shmuel, do you want to introduce yourself?
Yeah. I'm Professor Samuel Itzikowitz from the College of Management Academic Studies, Commerce. I'm the founding dean of the Computer Science Department there. I founded it in 1998. I'm here more as initiating the first academic course in Bitcoin in Israel, as far as I know, in the Computer Science Department. It was a course that I conducted last year, in which the third-year students, it was a seminar in which took place in which the third-year students took it. As far as research is concerned, I'm a beginner in this field, and I'm starting to work on it in terms of process mining, not data mining, but process mining. It's a relatively new field in which you are trying, using various tools to find out hidden processes that are actually hiding in a specific process. Thank you.
Hi, I'm Ben-Sasson. I am an associate professor at Technion, Israel Institute of Technology. My involvement in Bitcoin is a little bit indirect. About 4 years ago, thanks to very generous funding from the European Research Council, I co-founded a lab that later became known as Skipper Lab that tries to reduce from theory to practice a number of interesting protocols regarding zero knowledge and proofs of computational integrity. And this is very tightly related to Bitcoin and its properties. I'll be talking about one aspect later in the afternoon about zero cash, and that's how I'm related.
All right, thanks. So I'll introduce myself as well for anybody who doesn't know me. I'm Aviv Zohar. I'm a senior lecturer at the Hebrew University at the School of Computer Science and Engineering. I've been researching Bitcoin, I think, since maybe 2011, where I was a postdoc at Microsoft, and we wrote a paper, I think one of the earlier papers on Bitcoin and red balloons. And I've been doing more work on Bitcoin since. Okay, so now I'll turn a question to the panel. I suppose since this is the Bitcoin academics panel, I'd like to really ask you what you think is the biggest open problem or the most interesting research direction that we should be looking at regarding Bitcoin. I think that's, maybe a lot of people here would want a nice PhD or something. What should we be working on? And I guess the students here could also say something about where they think they should be going with their research.
So I think that won't be a surprise, but obviously scalability, which is my research topic. So I think in academia we're in the unique position to actually do some research on the fundamentals of Bitcoin, which then may help the entire ecosystem of Bitcoin 1.0 or Bitcoin 2.0. And it's research that isn't aimed at monetization directly, which is we're in this unique position to do that, and I think that's definitely where we should concentrate our forces.
I think science does basically two things. It explains and it improves. I think explaining Bitcoin, like what is the theoretical model that captures what's going on and why this has value and how it can evolve is a very interesting fundamental question that has to be answered based on which you could build further things. So that's in the explaining domain. And of course, there's all the improving. You know, there are many, many things that you want to improve. Scalability is one. So explaining and improving.
Yeah, so I think that the most consequential problem to research is actually whether Bitcoin can work well in the future over the long term or not. So that might not be the problem that is the easiest to research. So you need to develop rigorous models and try to claim whether your proposal for improvements or just the analysis of the protocol as it is works well. So it might be difficult, but in terms of being consequential, that is the most important research.
I would add to what Eli said that I think there is one field that has to be studied in terms of process mining is how is it developing, what are the hidden processes that are hiding inside, what are the bottlenecks, for example, and so on.
Okay, thank you. So, Eli, you mentioned that part of the job of scientists is to explain, right? And one of the things that we do a lot is we also teach students. So, and I know Shmuel has established a course on this. So how do you think we should teach, and who do you think should learn the protocol at this point, right? It's not prevalent, it's not everywhere. Is this something that you could see going into undergrad curricula or something like that?
That's me.
Yeah, so I'll be happy to hear both of you, actually, right?
Okay. One of the major problems that I faced when I decided to initiate such a course is theoretical background, existing theoretical background. At this stage, the number of academic papers that had been published is very limited. And there is no, of course, textbook, and it's in the very beginning. So to have such a course in the undergraduate level, I think it's a problem unless it's a seminar in which the existing papers, or at least most of them, are being introduced to the students, and they themselves read it and explain it and show understanding of what's going on in each paper and so on. At this stage, I think in any further step in the undergraduate level would be difficult. We will have to wait a few years to see more papers, and perhaps a textbook will be written somewhere.
So I completely agree with Professor Itzikowitz. If you look at the curricula we teach in undergraduate courses, it is, very stable, and usually, you learn analysis, algebra. These are things that have been known for 200 years. So computer science is younger. You learn Turing machines, 60, 70 years, algorithms from the 1960s and 70s, and there's a reason. It takes time for us to mature and understand. So we all grapple with these questions. Do I want to teach a course on Bitcoin, this semester? And I want to hear your answer to that as well. I agree that right now I don't feel comfortable doing anything more than a seminar where, I just present the little bits I know. I don't even know what will be the introductory lecture where I say, okay, Bitcoin is, what is it? I don't know. I don't exactly know. Okay.
Christian, do you want to say something?
Yes, we actually do teach it in our course, Distributed Systems. Of course, we don't have enough material for a whole course dedicated to Bitcoin. However, we believe that having an introductory lecture on how Bitcoin works and how what you can build on top of it is incredibly important, especially because these are the people that will eventually become your engineers. They need to understand at an early stage what Bitcoin is, how it works, and we integrated it as a double-hour lecture in the Distributed Systems course, which is taught to grad students as well as undergrad students from electrical engineering and computer science. And it proved to be a great recruiting ground for students to then come and do projects with us, projects that have been hugely successful. We created a hardware Bitcoin wallet, we created a Bitcoin vending machine, and I mean, these people need to understand what Bitcoin is and what its potential is, so that they can then focus their studies towards that direction if they're interested in it.
Do you want to comment, Iddo?
Maybe just ask Christian a question. So what kind of a task do you give to an undergraduate student who participates in such a course?
Well, it's a lecture, so it's we stand in front, we tell them what Bitcoin is, and it then turns up in the exam. That's what we do. And it's usually the part where students have very few problems, because it is an interesting topic. If you can interest a student for a topic, then they'll have no problem at all learning it.
What about you?
Okay, so I'm definitely at the point where you are at the moment. I'm a bit cautious about teaching undergrads too much about the protocol. So I do have a seminar that's starting this semester on Bitcoin, and by now there is a sufficient mass of papers that is serious and very nice, and you can follow a lot of things like how mining pools work through a paper that talks about mining pool incentives that Many's written, or I don't know, selfish mining papers and so on. There's a lot of nice aspects of Bitcoin to understand, and hopefully somebody who finishes the course will emerge being able to do research on Bitcoin. That's the goal. But having heard what Christian said, I also agree that to some level you can show this to undergrads, and you can maybe reverse the question. You can say, okay, we want to design a monetary system. Let's do it now. And you can go through like a mental exercise of we need a server where maybe we keep the money, we have records, electronic records, and you can even show this to an undergrad introductory course to some degree. And then you say, what happens if we want to get rid of this server? And now you start introducing ideas that Bitcoin is slowly added, right? The peer-to-peer network, how do you build it, how do you maintain it? There's a lot of lessons to be learned there just from this question of how to build a monetary system. And the first answer you come up with is the regular system, is the centralized one. The more sophisticated one would also bring you into questions of, you would understand what a consensus mechanism is by asking the question of how do I keep records in sync between different nodes and so on. So I think there are hidden lessons in there. Okay, so let me ask another question from a different angle. So So Bitcoin was born in a, in a fairy tale story, right? It was released on an anonymous forum, read by very few cryptographers that were not all necessarily academics. I understand it was a mixed crowd. But this definitely, the white paper did not come out at a conference or a journal. On the other hand, it is really based on a lot of deep results in computer science, a lot of things that computer science have brought forth. So do you think, if you'd see Satoshi's paper in one of your conferences in your fields, would it have had this success that we would now be sitting here in a panel, and talking to regulators about this new currency?
I would like to say that yes, but probably no, but that's okay. The academic world, like all other worlds, is conservative, and we're very good at judging things that are very similar to things we saw in the past, and that's true of any other world. And when something completely new comes around, it's very hard to see that it's new because it's hard. I mean, many new things or claimed new things come all the time, and most of them, like of all patents, whatever, 1% ever makes a profit. But it's very hard from the start to see which are the good ones. So the fact that the academic world did not see the potential in Bitcoin at the start, like many other worlds, like the financial and regulatory, that's, it happens. That doesn't really matter much. What's more interesting is what's happening now. I think we're seeing a little bit more of acceptance of Bitcoin-related research. We're not there yet. It's still not as acceptable as an academic research area as our other areas, but we're improving there, I think.
Anyone else?
Yeah, I think we're definitely seeing more widespread adoption of Bitcoin in academia. When I published my first paper over a year ago, it was the only Bitcoin paper at that conference, and it was a peer-to-peer conference, which is, well, should be right, the real match between the topics. Now we start seeing more and more papers being published, and the acceptance rate of Bitcoin papers, at least in my field, is incredibly high. I haven't had to resubmit a single paper twice. It's
You're doing good research then.
What?
You're doing good research.
I've actually had the opposite experience. I've never had to submit a paper once on Bitcoin. Some of them are still pending.
Okay, in that case I'm lucky. But it's starting to move. I think it's not like all this work is suddenly jumping up and comes out from nowhere. There is a lot of work involved in creating a scientific publication, and the peer review process itself is quite rigorous and it's slow. I mean, we started working on it. You said 2011, I started working in 2012, and it takes some time to get these things published and to get these through review. So it's no wonder that we're, well, wouldn't say late to the game, but we're lagging a bit behind. On the other side, depending on regarding the non-academic background of Satoshi, I think we shouldn't forget that much of the paper's appeal was because it had this background story. When I first read it in 2009, I immediately thought, okay, this is something I can be behind. There was a little bit of crypto-anarchist inside me, I guess. But initially, it was this community made up of liberalism and crypto-anarchy, which kept this project alive until everybody else realized what really was behind it. So I think it not being published in an academic setting might have been a clever marketing trick.
I agree that we need some time for this relatively new field to build up. However, I'm just curious what the quantum computing will do to this kind of field, because while more papers are being published about the Bitcoin, more research is being done. More research is being done also in the quantum computing. So I wonder which one will catch up earlier.
My bet is that quantum isn't a worry for any time soon. And also a lot of the cryptography is not, okay, some of it is resilient to it, but who knows, making predictions is hard, especially about the future.
Yeah. So I would actually speculate that Satoshi was a PhD student. That was my guess. Everybody has his favorite theory of who Satoshi is, right? And I always am amazed when people think it's this professor or that, and knowing that Satoshi wrote the code, or if he's not many people, if he's just one person and he wrote the code, he probably is not a theory professor at any university, because it's a secret, but we don't code that well. The students do a lot better than we are. And taking 2 years off to write the Bitcoin client like Satoshi wrote that he did initially, and I believe that that's what he did, is not something that we can manage. And the paper, when you see the paper itself, it really looks like an academic paper. It has citations. I mistook it for LaTeX at the beginning. Apparently, if you look at the metadata of Satoshi's paper, this is a nice thing that I found out. It appears to have been written in OpenOffice, which is the biggest clue that he might not be a PhD student. If it was compiled in LaTeX, then that would be a very good tell. And apparently some people can see this. They look at the fonts and they know immediately that it's not.
Unless he wrote it in LaTeX and then before publishing he did cut and paste.
Right, he did cut and paste, of course. But one of the things that I like about Satoshi's paper, if you read it, he gives a formal proof of the correctness of his algorithm in there. He gives a very high-level overview, right? The code is eventually what convinces people. But there's also, he talks to different audiences. He supplies code to compute the probability of a chain being reversed. And he also gives a table for people who don't want to write the code and run it on a machine, right? So he talks to a lot of audiences. He's a very good writer. He does these things well. I wouldn't be surprised if he has academic background. Okay, so while we try to ramp up academia, right, Bitcoin development is kind of steaming ahead, right? So are we in any position to affect things? I mean, will academic findings ever change the protocol? Is the protocol too far into the future, dealing with problems that we haven't even gotten to, so that we have nothing to really say or really contribute?
So my first answer would be that I don't know. I hope we will contribute. But the more, I think, essential answer is that as scientists, that's not what we should, that's not our goal to have things necessarily adopted. It is to explain and improve on very theoretical levels. And if we do, and to educate, as you added, of course. And if we do those three jobs, then it's up to the world to decide, what gets taken. The same is true for, design of chips and compilers and then the web and so on. Academia doesn't, Google doesn't wait for us to do the next thing but we do provide a service to humanity. That's our mission.
I think you said it best in your first answer when you said that research has this dual role of creating an understanding of what is there, creating this safety net below what is the state of the art, and then I do believe that we also have the capacity of creating new stuff on top of what is the current state of the art. So if the industry runs away and we're lagging behind, then we still have this role of making sure that what is actually being done is secure and works by proving its security, of course.
Yes, so those are two very different processes. So on the one hand, we have like the cryptocurrency community. So the Bitcoin developers themselves are quite conservative, and they don't come up with very significant innovations for the most part. But there are all these other guys who just publish, or maybe not the word, make public some white paper, and then get some other guys to put money into it and watch the experiment goes and see how it goes. And this kind of a process may develop into something good over time. And in academia, we are more conservative, and it's a very different kind of a process where we try to analyze the models in a rigorous way and see what can work and suggest improvements. And which one of these two very different processes will lead to better results, that's hard for me to say.
Okay. So Eli, I actually want to confront you with what you said, because you're actually building an altcoin. Am I right? It's part of what you're doing.
I'm not commenting on that. We published a paper. We have academic grade code running, and we're contemplating what can be done. But you know what? Even if
to release zero cash as a running platform, or open sourcing, something on GitHub that's.
First of all, a lot of the code is out there already.
Okay.
There's libsnark, which gives the engine, the cryptographic engine. It's already out there. All coders and hackers are more than welcome to play with it. Interface with Bitcoin will also be released when it's stable, open source, MIT license or something like that. The white paper is out there. On what to do more than that, where the co-authors are sort of contemplating and deliberating. It's I don't know, but whatever the outcome is, again, it doesn't necessarily mean depends what the world will say, right? So.
Okay, so we have 8 minutes, so I'll be happy to take some questions from the audience, if you have any. So I see Ron there is raising his hand, and Shaul. Are there microphones around, or? So Ron, just go ahead and ask.
So I've been to quite a few Bitcoin conferences in the last year, and the only two in which I've seen an academics panel, to my recollection, were here in Israel. Do you have any? So first of all, thanks for coming and being here and working on the subject. How do you see Israel, or academics in Israel, or Israelis academics relative to other places in the Bitcoin sphere?
So I'll comment shortly. I think we've got a small concentration of academics, small being, so far, like 2-3 places that have done it, and in Israel everything is close by, so this is good. If Christian is there in ETH, I don't know how many people around you are dealing with Bitcoin. Maybe you can tell us later. But distances in other countries are greater. I think in the US there is now a core of researchers that is forming. You can see people who have received grants from the NSF and so on to research Bitcoin, people who are starting to do it in Cornell, in Princeton, and in other places, and they're starting to form their networks. And you see conferences starting to accept Bitcoin, or workshops starting to pop up, and I think academics are ramping up to it, and groups will be forming. And some of this movement has actually been uncategorically, this is not the usual thing, but more from the bottom up. The students, like in undergrad level, have heard about Bitcoin, have read about it, they're enthusiasts, and they go up to people and say, I want to do a thesis about Bitcoin. Can you be my advisor? And right, Jonathan Levine is here. He was telling me the same thing, and he had a hard time finding somebody in Oxford who will teach him, who will be his advisor regarding Bitcoin. And Oxford is a very good place, ranked very highly in computer science. So this is part of ramping up, I suppose. Anybody else? Maybe Christian?
So yeah, I can speak for Zurich. So far, I am the one in the distributed computing group which is doing Bitcoin, and there's another PhD student in the cryptographic institute, and we're like the 2 PhD students which are working on it. However, being the contact persons for Bitcoin is obviously a huge plus when it comes to student projects, because there's a huge interest in doing projects related to Bitcoin from the students. And I'm currently supervising 9 students doing projects on Bitcoin, and they'll be happy that I mentioned them, by the way. I think the reason why it's Israel and Zurich which are particularly interested in Bitcoin is because both of these have a huge distributed computing community. We have several postdocs from us are from Israel, and I think the opposite is also true. And distributed computing is just a natural place to start researching Bitcoin, I guess.
Although in our case, it's not the reason, right? Eli is in cryptography. I'm from the econ CS side, which also matches, but Adi Shamir is also a cryptographer and so on, right? And so we have people coming from, I think it's very interdisciplinary. So a lot of things match Bitcoin, right?
My answer is very simple. It's the Israel Bitcoin Foundation and Meni Rosenfeld that appreciate academics, and they make the decisions. I think that's the difference. So talk to your peers in the world that they,
Okay, we had maybe another question, Shaul?
Touch my kind of question a bit, but do you think we've reached a critical mass in academia to justify either a peer-reviewed publication on Bitcoin or an annual conference that takes multidisciplinary academics and works solely on cryptocurrencies and things in that domain?
So do you guys want to comment? I have my answer, of course.
I'm very opposed to conferences in general in the academic world, and they serve the wrong purposes, especially in computer science, but that's a different matter. There are right now, I don't know, at some point, there are right now some conferences that already naturally attract like financial cryptography, and the network aspects are taken care in other places, and crypto and S&P. So I don't know, at some point someone has to do it.
So at the moment, there's a Bitcoin workshop running with the Financial Cryptography Conference, and it's like you would probably imagine. Financial cryptography is mostly cryptographers, and the Bitcoin workshop there, I think, is becoming more and more interdisciplinary. But to be honest, you need only to look at this table to see how multidisciplinary we are, how single disciplinary we are. We are missing economics professors here. There's nobody from the law school. There's nobody from sociology. I've just met Ilan, who's sitting in the crowd here, and is interested in Bitcoin. But I know I have a lot of interaction with economists, and they're only now really getting into Bitcoin and starting to take it seriously. I know Paul Krugerman's been taking it seriously more in the sense of bashing it over the newspaper for quite a while, but that's actually helped, because when Paul Krugerman writes a lot about things, economists read him and see what he's writing about. But there are now advocates in economics for Bitcoin as well, or for the study of Bitcoin. It's a new thing, and I think it deserves to be studied. Okay, any more questions? We have more time.
I guess you can answer as quickly or as in depth as you want. But I'm just curious if you had to rate Satoshi's paper as an academic paper on a scale of 1 to 10, each of you.
You guys want to answer?
I think that in retrospect, like when he comes out of hiding, I think he should be considered at some point, for the Nobel Prize in Economics and the Turing Award for this, for his work. But again, I already answered before that if I had seen the paper in 2008 on some conference program committee, I probably would have rejected it. But that's the way of the world.
Yeah, it would definitely have been rejected. It's very high level. It doesn't go through all the details. And actually, you can see if you follow that that posting where he published his paper on the cryptography list, you see a lot of questions. Hal Finney is asking him questions about how the protocol works and so on. These are things that aren't clear from the paper. Every time I teach a student about the paper, they ask the same questions. It's not different. The paper is very high level. Nobody believes it works, right? And I think the greatness to what Satoshi's done is actually release the source code. This is the key. Okay, we're out of time, exactly. So I'll thank all the panelists, and please join me in doing that.